Northern Lights. The Northern Lights, or Aurora Borealis, offer an entrancing, dramatic, magical display that fascinates all who see it, but just what causes this dazzling natural phenomenon? It is a vivid demonstration of the Earth's magnetic field interacting with charged particles from the Sun. It's also beautiful, and worth braving a cold night out when visiting the high northern, or southern, latitudes. Auroras are centered on the Earth's magnetic poles, visible in a roughly circular region around them. Since the magnetic and geographic poles aren't the same, sometimes the auroras are visible farther south than one might expect, while in other places it's farther north. The aurora borealis forms when charged particles emitted from the Sun during a solar flare penetrate the Earth's magnetic shield and collide with atoms and molecules in our atmosphere. These collisions result in countless little bursts of light, called photons, which make up the aurora. In the Northern Hemisphere, the auroral zone runs along the northern coast of Siberia, Scandinavia, Iceland, the southern tip of Greenland and northern Canada and Alaska. Auroras are visible south of the zone, but they are less likely to occur the farther away you go. The Southern Hemisphere auroral zone is mostly over Antarctica, or the Southern Ocean. To see the Southern Lights, or Aurora Australis, you have to go to Tasmania, and there are occasional sightings in southern Argentina or the Falklands, but those are rare. Here are some dazzling facts about these light shows. Aurora displays are created when protons and electrons stream out from the solar surface and slam into the Earth's magnetic field. Since the particles are charged, they move in spirals along the magnetic field lines, the protons in one direction and the electrons in the other. Those particles in turn hit the atmosphere. Since they follow the magnetic field lines, most of them enter the atmospheric gases in a ring around the magnetic poles, where the magnetic field lines come together. The air is made up largely of nitrogen and oxygen atoms, with oxygen becoming a bigger component at the altitudes auroras happen, starting about 60 miles up and going all the way up to 600 miles. When the charged particles hit them, they gain energy. Eventually they relax, giving up the energy and releasing photons of specific wavelengths. Auroras are centered on the Earth's magnetic poles, visible in a roughly circular region. Satellites can take pictures of the aurora from Earth's orbit, and the images they get are pretty striking. In fact, auroras are bright enough that they show up strongly on the night side of the Earth even if when we're looking at them from another planet. The northern lights look like fire, but they wouldn't feel like one. Even though the temperature of the upper atmosphere can reach thousands of degrees Fahrenheit, the heat is based on the average speed of the molecules. Auroras are relatively dim, and the radar light is often at the limit of what human retinas can pick up. Cameras, though, are often more sensitive, and with a long exposure setting and a clear dark sky you can pick up some spectacular shots. One of the most difficult problems in solar physics is knowing the shape of a magnetic field in a coronal mass ejection, CME, which is basically a huge blob of charged particles ejected from the Sun. Such CMEs have their own magnetic fields. The problem is, it is nigh impossible to tell in what direction the CME field is pointing until it hits. A hit creates either a spectacular magnetic storm and dazzling aurora with it, or a fizzle. Currently there's no way to know ahead of time. Seeing the astronomical phenomenon known as the Northern Lights, aka Aurora Borealis, literally northern dawn, is a bucket list item for many people. These dramatic curtains of colored light, which appear high in the night sky in the northern hemisphere, are most visible in the middle of the night and the dead of winter, and in remote, dark areas. Humans have seen and made stories about the lights since prehistoric times and, more recently, conducted scientific studies on them.
If you did find this video helpful, like and subscribe to the channel and enjoy more videos which will help you know more about various natural phenomena and history of our planet.